having our conversations with luminaries at what we usually call the cutting edge of science and spirituality. But by spirituality, we just mean total self awareness and nothing necessarily theological or religious, although there are overlaps, of course. Today, it's my great pleasure to welcome Professor Avi Loeb. Uh, he's a professor of astronomy at, uh, at Harvard. Actually, his proper title, Frank B. Baird Professor of Science at Harvard University, where he was the longest serving chair in the history of astronomy in the department from 2011 to 2020, and where he directs the Black Hole Initiative, an institute for theory and computation. Dr. Loeb is a member of he's a member of the President's Council of Advisors on Science and Technology. He's on the advisory board for the educational platform Einstein Visualized the Impossible. He also chairs the advisory committee for the Breakthrough Starshot initiative and the board on physics and astronomy of the National Academies, and serves as the science theory director for all initiatives of the Breakthrough Prize Foundation. He's the author of 5 books and 800 scientific papers. Avi is an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected um, Loeb as one of the 25 most influential people in space. He lives near Boston, near Massachusetts, my old hangout. I read this long introduction, Avi, for one reason. What we are going to say, or what you're going to say, is so outrageous that were it not for your credentials, people would think you're as crazy as Deepak Chopra. So, welcome to the show. Thank you for joining me.
Thank you for having me.
So, Avi, may I call you Avi,
Yes.
Professor?
No, you can call me by the way, all the labels that you mentioned, all the honors that I received, they are not as meaningful to me as the pursuit of the curiosity, the childhood, the interest in figuring out what the world is like. And that is really what I'm about, not these titles.
Absolutely. Now, you know, you're very highly credentialed, you're famous, you're an academic, but I have to tell you, um, most people don't know who you are or who I am. Most people where this is going. So I would like to start this conversation by asking you a little bit about your childhood, where you grew up, how you came to be interested in what you're doing. Because I noticed, I've been reading your book, and I noticed you have deep interest in, as you said, you're curious, but you're also open to possibilities that people don't usually entertain in academia. I've found the conversations stay within academia, they don't get outside, and all the arguments are within academia also. So I'd like to actually know a little bit for our general public. We reach about 15 million people in the end. They'd like to know, who is Avi? Where did he grow up? What was his childhood like? What were his parents like? And why is he at Harvard looking for extraterrestrial life?
Yes, so in fact, my book also discusses my roots because I think they are relevant for who I am right now. And in fact, I'm very proud of where I came from. I grew up on a farm and we used to have chickens, and I collected eggs every afternoon. And that taught me some discipline, but I was mostly interested in philosophy at
Which farm? Where? Which country?
in Israel, a farm not in a village not far from Tel Aviv. I used to drive the tractor to the hills of the village every weekend and read philosophy books on my own. And I was very interested in the deepest, the biggest questions about our life. and I thought of becoming a philosopher. That was my ambition. But in Israel, there is obligatory military service at age 18. And I had two options, either to run in the fields with a gun or to pursue intellectual work in the context of physics, because physics is useful for the defense of the country. And I was recruited to a program that allowed me to finish my PhD in physics and mathematics at age 24. And while doing that, I did research.
Avi, where did you do your PhD?
It was at the Hebrew University in Jerusalem, Israel. And
I've been there. I've been there twice, and I've also been to the Albert Einstein museum and location there. So
yeah, Jerusalem is beautiful. It's sacred to at least three religions, but maybe even more. And it's just a very peaceful city. And I loved being there while I was doing my degrees in academia. And at the same time, I also led a project that was funded by the Star Wars Initiative in the US and of Ronald Reagan. And that brought me to Washington quite often. And in one of the visits, I went to visit Princeton. And there I was introduced to Freeman Dyson, who introduced me to John Bacall, an astrophysicist, that ended up offering me a 5-year fellowship under one condition, that I'll switch to astrophysics. I didn't know anything, how the sun shines. I came up from a background in plasma physics, physics of hot gases. And then it took me, when I got there in 1988, it took me about 3 to 4 years to actually learn the vocabulary. It was very difficult being surrounded by clever people and not really in my territory. And the only reason I accepted this position is because it's rarely given, even to people that focus on physics. So I said, I'll postpone my interest in philosophy. And then there was a faculty position being offered at Harvard University. And the first person that was offered that position declined it because the chance of getting tenure were really small at that time. And he went somewhere else, and they just gave it to me. And for me, it was not an issue not getting tenure, because I could always go back to the farm. I had plan B. And then eventually I got tenured there a few years later. And then I became department chair a decade later. And as you mentioned, I served in that post for 9 years. And I'm very different because of my background. I'm very different than astronomers that you usually meet, because I was interested in philosophy early on. Turned out that even though my marriage to astrophysics was arranged by circumstances, I ended up recognizing that I'm married to my true love, because there are deep philosophical questions that astrophysicists can address, such as how did the universe start? Where did we come from? And is there life elsewhere? How did life start? Very deep questions, and we can address them now with scientific tools. And frankly, my point of view is that not only we are probably not alone, but we are not the smartest kid on the block. We are not the sharpest cookie in the jar. And that relates to my book.
So let's talk about your book first, and then let's get into some philosophical conundrums and also some scientific conundrums. But first, let's talk about your book. I'm speaking to Professor Avi Loeb from Harvard University. He's an astrophysicist, and he's written this extraordinary book. It's called Extraterrestrial, the first sign of intelligent life beyond Earth. What's the basis of this book? I've read it, but I want our audience to understand why you wrote this book and what they can expect to find and how it will arouse their curiosity about their role or significance or insignificance in the universe. What's in this book without giving it all away?
So throughout my career, I worked on the early universe, how the universe started, how the first light was produced by the first stars, I worked on black holes. I'm actually the founding director of the Black Hole Initiative at Harvard, which brings together philosophers and scientists. So it's a very interesting environment. And then this object, Oumuamua, was discovered in October 2017 by
Pronounce
a
it.
telescope in Hawaii. Uh,
Pronounce Uma Uma.
no, Oumuamua. And
Umua.
it,
Umua.
yeah,
Okay. Tell us.
Oumuamua. And it means a scout in the Hawaiian language, or a messenger from far away. And it basically is the first object that we spotted close to Earth that came from outside the solar system. So it's really interesting, but astronomers thought, oh, it must be a rock, just like all the rocks that we have seen in the solar system before, the asteroids, the comets. A comet is just a rock that is covered with ice. So when it gets close to the sun, the sunlight warms it up and the ice evaporates into the cometary tail, the beautiful tail that we see behind comets. And so they said, well, it must be a comet from another star, okay, and that was ejected from its environment and got to our solar system. The only problem is that as time went on and we collected data on this object, it turned out that it doesn't have a cometary tail. In fact, there is no gas around it. The Spitzer Space Telescope looked very deeply around it, didn't see any dust or carbon-based molecules. So it's definitely not a comet. But then, so people say, okay, maybe it's just bare rock, okay? The problem with that is that the object exhibited an extra push away from the sun. And usually this push is, in the case of comets, from the rocket effect. Gas evaporates and pushes the object forward. And in this case, there was no gas. So what gives it this extra push? The only possibility that came to my mind is the reflection of sunlight. You know, just like in a sail, when you have wind reflected off a sail on a boat, you get the boat to move. And the same thing can happen to this object, that the reflection of sunlight could push it forward. And all the data was consistent with reflected sunlight. The force declined as the object went farther from the sun in the way that you expect from reflection. But moreover, the object was, as it was tumbling, as it was spinning every 8 hours, its brightness changed by a factor of 10. So the brightness is basically reflected sunlight. And so that means the area of the object on the sky was changing by a factor of 10 as it was spinning. And that means that the object has a very extreme geometry, most likely flat. If we try to fit the change in light, the most likely geometry was a flat geometry, like a pancake. And if you imagine a piece of paper tumbling in the wind, you know, a change by a factor of 10 in the area that you see of the piece of paper is a lot. And we've never seen something like that before. So altogether, there are several other anomalies about this object. It didn't look like an asteroid, didn't look like a comet. It looked like something that we have never seen before. And I just suggested maybe it's a sail that is pushed by light, which is called the light sail. And I wrote it in a scientific paper that got published within a few days. And then the media got a hold of the story and it became viral. And the book describes all the details about the object. Why do I think that it might be artificial? And of course, the implications are obvious, are very important, because it means that we are not alone, that there are other technologies. Maybe we are not the smartest kid on the block, you know, and we want to know more about these objects. You know, it's very similar to walking on the beach. And most of the time you see seashells or rocks that are swept ashore. And every now and then you see a plastic bottle, and that tells you that there is a civilization that produced it. And so my point is really simple, that we should examine all the objects that enter the solar system from outside, and we might find some space trash or space junk or even functional devices, you know, technological things out there. And we have not been able to do that until recently. And so that's the main premise of my book. But there is another part to the book which you might find interesting, and that is the response of the community, the scientific community, which I find completely unexpected and inappropriate, which is to push back, to say there is a taboo on discussing any technological signature as an explanation to anomalies that we see in the sky. So my colleagues are not willing to engage in a discussion about this possibility. And that's unfortunate, because it's basically discourages young people from thinking in this direction. And there is no funding for searching for technological life out there. There is funding for maybe searching for primitive life, like microbial life, but not technological. And I think it's a missed opportunity because the public is extremely interested in that. And obviously, the public funds science, so scientists should respond to that. And obviously, if you step on the grass, and you say, well, look, the grass doesn't grow, then obviously it would not grow. So we will never find wonderful things if we are not ready to discover them.
So let me ask you a couple of questions. In the book, you do suggest that this object is a technological object produced by possibly an advanced civilization that could have existed maybe millions of years ago or tens of millions of years ago and possibly still exists, right? In some exoplanet, right?
Right.
And then in the book, you also talk about microbial life and you talk about metabolism and looking for microbes in places like Mars, and that might be evidence. So, given all that, if I go on the internet and I look at the latest estimates, I'm told, and I checked this morning again, there could be 2 trillion galaxies out there, 700 sextillion stars, and uncountable trillions of planets, and possibly 60 billion habitable planets out there, exoplanets in just the Milky Way galaxy. Is that possibly true?
Yeah. We now know there was actually a paper a few months ago using the Kepler satellite data and arguing that's the latest hot, fresh news from astronomy that about a half of all the sun-like stars have a planet the size of the Earth, roughly at the same separation. And what that means is that you could have liquid water on the surface of those planets and the chemistry of life as we know it. So in my mind, life as we know it, including ourselves, is very common. That should be the mainstream assumption. That should be the most popular view. And then we should just go out and search for it. But instead, people dismiss that possibility because they prefer to feel that they are special and unique, And this story dates back to Aristotle. Aristotle, the Greek philosopher, the ancient Greek philosopher, argued that the Earth is at the center of the universe. And there was this very beautiful picture of spheres around the Earth. And for 1,000 years, people believed that idea because it's very flattering for us to be at the center. When my daughters were young, they thought that they're very special and unique and that the world centers on them. But then they went to the kindergarten and they met other kids and they changed their perspective because some of the kids had qualities better than them. So for our civilization to mature, we have to find others. And of course, the view of Aristotle was demonstrated to be wrong by Copernicus and by Kepler and by Galileo Galilei. And at first, the philosophers near Galileo, they said, we think that you are wrong and we don't want to look through your telescope. So they put him in a house arrest. So he was in house arrest. By the way, I'm in house arrest, but for a completely different reason because of the pandemic. So he was put in house arrest. And then that maintained the ignorance of the philosophers at the time. It didn't change the fact that the Earth moves around the sun. Reality, my point is very simple. Reality stays whatever it is, irrespective of whether we ignore it or pay attention to it. And we can choose to bury our head in the sand and say, there are no aliens. It's never aliens. We should not even consider the possibility of searching for technological signatures up there. and then we will never find them. But on the other hand, if we want to get a better sense of reality, we should check our neighborhood, and it will change our perspective about our lives. And let me give you an anecdote. There is a student in the English department at Harvard that after looking at my book, she decided to have a PhD about the theme of my book. So she invited me 2 months ago to a thesis exam, to a PhD exam. And one of the professors, one of the examiners asked her, do you know why Giordano Bruno was burnt at the stake? And she said, well, it's because he was an obnoxious guy and he irritated a lot of people around him. So that's what happened to him. And the professor said, no, it was because Giordano Bruno said that other stars are just like the sun, and that they may have a planet like the Earth around them, and you may have life on those planets. And then the church found it offensive because if there is life elsewhere, that life could have sinned, and you need duplicates of Christ. You cannot just have one Christ on Earth. You need to have multiple Christs, each of them visiting each of these planets to save those lives. And that was unacceptable to the church, so they burned the guy. Now, fortunately, now we know from scientific data that Giordano Bruno was correct about other stars being like the sun. He was correct about them having a planet like the Earth. And my point is simple. I tried to inject some scientific reasoning into the discussion that was at the PhD exam of that student. I said, then that's very good news, because we can actually experimentally test this theology that claims that, so we can go to those sites, find the life there, and check if they sinned. And if they sinned, we can ask them, did you witness Christ? And if they say no, then that proves this theology wrong. So that's an experimental test.
Avi, amazing stuff. We've been already 23 minutes. This is a great introduction to everything we wanted to say. Now I'm going to actually go a little further and ask you to respond with short answers, because we need to have a 1 hour discussion and cover a lot. But this is amazing about the book, what you've said. So my first question is, so given all what you've just said, on scale then, planet Earth is not even a speck of dust in all the beaches of the world. It would not be even one speck of dust in a void that is unimaginably large, intergalactic space. We would not be even one grain of sand in all the beaches of the world. Is that correct?
Yes, this is correct.
And yet we have a mind like Avi, and Stephen Hawking and many others, who can go deep here to unravel the secrets of the universe. That's a question I want to come to. You mentioned something just now that leads me to ask you 2 questions. And let's see if we can cover everything in 1 hour, because otherwise we'll have to have another conversation. I'm very happy to do that. Okay.
I'll be as brief as possible. Go ahead.
So no, don't be. We can also do another conversation. But 2 people come to mind right now. One is Freeman Dyson that you mentioned, and the other I'll come to in a second when you mentioned Jesus Christ. But Freeman Dyson. So, I had once upon a time a very feisty debate with, what's his name? Richard Dawkins.
Yes, I know him.
He's a self-professed militant atheist. So I was And of course, everybody has their own definition of atheism too. So, some are old-fashioned atheists. Jesus Christ is not divine, or Moses wasn't divine, or there's no dead white male in the sky. And some are different kinds of atheists, and there are all kinds. But in any case, we had a very feisty debate, and I quoted Freeman Dyson from his book Infinite on All Sides, or Infinity on All Sides. And there's a statement right in the end of the book: every quantum experiment forces the atom to make a choice. I just quoted it, and Dawkins lost his temper. He said, first of all, Dyson never said that. He could not have said that. You should apologize to him, and he should sue you. So I wrote, I wrote a letter to Freeman Dyson, email. I said, please sue me because I quoted you. I said this. And so Freeman Dyson actually sent an email back to me and to Dawkins. And I've kept that email because I want it preserved for posterity. And he said, 3 riddles have confused me all my life. 3 riddles. Number 1, the unpredictable movement of atoms. Unpredictable. He didn't say random, he said unpredictable. To me, that's a very fine distinction. Number 1, the unpredictable movement of atoms. Number 2, a universe fine-tuned for mind and life. And number 3, our own consciousness. He said, I do not know the answers to these 3 riddles, but I have a feeling that they are somehow connected. Please respond.
Yeah, well, first of all, I should say that what the universe teaches us, and it teaches me, I cannot speak for everyone, but there is obviously a very big message that I learned throughout my career by studying the sky, and that is modesty. You have to be modest. You have to be humble. We represent, as you said, we represent such a tiny speck in the big scheme of things. We also, the most important is we live for such a short time, compared to the cosmic history. We are clearly not central players in this play, okay? And for us to be arrogant implies that we are also ignorant. The only person I can think of that can be arrogant or can say, like, there is no spiritual, to make conclusive statements like that, a person that doesn't see the full picture, that's quite possible. I mean, obviously animals don't see the full picture. They don't have our ability of being conscious, and as a result, they miss something. But fortunately, we have that, and we should be modest. Okay, that's the basic point. But speaking about, of course, there is, and Freeman Dyson was completely right on all 3 points. I completely agree with him. Now, with respect to spirituality or religion, I think it's not in conflict with science, the way Dawkins is arguing. And because science is trying to understand how the world works, okay? So it's just like taking a watch and opening it up and trying to figure out how it works. Now, you might say, I don't want to look inside the watch. I appreciate the watch from the cover. But as they say, don't value a book based on its cover. You need to understand something. You need to really get into it. Exactly.
I like the cover.
So my point is simple. By doing science, you gain a better appreciation of how extraordinary the world is. And Freeman mentioned some of those issues. And to me, I will add to that the fact that the laws of physics that we uncover here on Earth, by doing experiments on Earth, they seem to apply everywhere, all the way to the edge of the universe. How is that possible? Why is it organized so well? When I go to in the morning and visit my daughter's rooms, they are in complete chaos. The universe could have been chaotic. There could have been regions that are described by different laws than our laws. If you look at human society, even though you have laws, people don't obey them. So somehow nature is in harmony, in such a perfect obedience, of the fundamental laws of physics. And that to me is a mystery. Also, the fact that the universe started very simple. It became complex today, but the initial conditions were really simple. Also, it started at a certain point in time. We don't know what happened before. I can give you my conjecture. One possibility is, there are two pillars of modern physics: quantum mechanics that Freeman Dyson was talking about, and gravity, the force of gravity that Einstein formulated in terms of his theory. And we don't have a unified theory that combines the two. If we had that, perhaps we could imagine a laboratory experiment where we create a universe out of nothing. By irritating the vacuum, we can create a new universe, a baby universe. And if we could do that, it would explain the Big Bang, because maybe the Big Bang has an umbilical cord that leads to a laboratory of a previous universe where people like us created a baby universe. That's our universe. And once we gain the scientific understanding of quantum gravity, we would create a new baby universe. So just like people, we have babies that make babies that make babies indefinitely. And you can imagine universes coming into existence this way.
So I'm realizing we're going to have more than one conversation. If you're amenable, we could do some more conversations, because I'm talking to other cognitive scientists, neuroscientists, and also cosmologists, and I'd like to take our conversations and relate them to the others. So, first of all, thank you for that answer. Now, secondly, I'm looking at the endorsements of your book. There's one by Sean Carroll, whom I hope to interview soon. But I did read his book, Something Deeply Hidden. And as you know, there are about 20 different interpretations of quantum mechanics. And Sean, in his book at least, posits the multiverse theory and seems to favor it. And in fact, if you read the write up on his book, he says there are many versions, infinite versions of you and me in infinite universes. So if that's the case, why not Jesus Christ?
Well, okay, I don't think this is a scientific suggestion, big proposal, because we cannot test it. And also it leads people to be lazy. Suppose a student gets a bad grade in an exam. Then the student would say, what's the problem? There is a copy of me that gets a good grade in another part of the multiverse. It's sort of like being on drugs. You are not really in one reality. There are multiple realities, and you don't hold any moral responsibility for what happens. I don't like the multiverse idea, because I enjoy ideas that are testable, that make predictions, that have contact with experiments, with reality. Because I think physics is a dialogue with nature. It's not a monologue. You have to listen to nature, and through experiments, you get feedback and you learn something new. And the idea of the multiverse is not like that, because we cannot do any experiment that will demonstrate that the multiverse exists. And so it could lead a student to be lazy and just say, oh yeah, there are copies of me everywhere that are doing better. And so, what's the point about talking about things that we can't really test? As a scientist, I'm talking as a scientist. Now, if you connect it to religion or spirituality, that's a different matter. And by the way, as I mentioned before, science can be a way of appreciating the universe, being at awe as to what we really have in the universe. And then you can dress it up with a religious or a spiritual layer. It's not in contradiction. These are completely different activities. The scientific inquiry is just trying to understand how things work, and we learn by experiments.
Therefore, you are saying that there's a whole branch of physics that is actually metaphysics, and that includes multiverse, includes string theory, right?
Yes, that's very unfortunate, I must say, because it's like a shoemaker starting to make cakes. Like, how can they call themselves physicists if they are proposing ideas that cannot be tested?
But the Avi, these are very significant people. Sean Carroll is at Caltech, and this is a theory that everybody is talking about. And theoretically, you could devise experiments in quantum entanglement that would give you more ideas about multiverses that are not locally approachable, but non-locally understandable.
Well, okay, so here is my, I have a very simple criterion for for a scientific idea or a paradigm. You have to put some skin into the game, meaning you make a prediction, and if that prediction is tested by an experiment, and you should be able to say it was wrong. Okay. The problem with many of these ideas that are currently in the theoretical physics community is that they don't put any skin in the game. They say, irrespective of what the experiments will show us, my idea will be right, because I can always adjust the idea such that it will fit any experiment. That is a problem. Without putting skin in the game, you cannot test it. Like, for example, Abraham in the biblical story heard the voice of God, okay, to sacrifice his only son, Isaac. Now, if Abraham had a voice memo app on his cell phone, he could have pressed the button and recorded the voice of God. And then he could have shown humanity that God exists. He didn't have that cell phone. It remains a story. So my point is, experimental evidence can make stories into reality.
I agree, but actually, on one hand, I'm very happy because I see physicists now engaging in metaphysics with mathematics. And so, it brings up the whole question of mathematics as a mental activity, and somehow it matches the laws of nature. So that gives me hope that we can have a conciliation between metaphysics and physics in the future. But never mind that. I'm going to ask you one or two questions, scientific, and then we go a little bit in philosophy. But if you're amenable, I would like to continue this conversation in the future as well.
I'll be delighted. Yeah.
Short questions now, very short.
Okay.
Please try and answer yes or no, okay?
Okay.
Can current science give an answer that ascribes a cause to the Big Bang? Current science, yes or no?
No.
Okay, so no cause can be ascribed to the Big Bang, number one.
Well, okay, we don't have a theory of quantum gravity. For that, you need a theory of, but there are proposals of what may have happened before the Big Bang, but they're not agreed on. There is no consensus.
Okay, so right now, we don't have an explanation for the Big Bang. Right. Secondly, if time does not exist prior to the Big Bang, how can we give a date to the Big Bang? How do we do that? How do we give a date to something that started when there was no time?
No, so my view is that there should have been time and there was something predating the Big Bang. It's just that the existence of the Big Bang is a consequence of Einstein's theory of gravity breaking down when the density of the universe was infinite. And the theory breaks down. It means that you need to replace the theory with something better that has quantum mechanics. And then you will be able to go through that Big Bang singularity that you don't know what to do with Einstein's theory, and time will continue. So I agree with you. By the way, the Big Bang is consistent with the biblical story that things started at a point in time. But I think that if we had a theory of quantum gravity, we would be able to go back.
So are you then suggesting that there is no such thing as timelessness?
Yes, because we cannot comprehend it. It might exist, but all of our experiences are in terms of a flow within time, right? So it's just like imagining something that we've never experienced. We can't do that. We can only imagine what we experience on a daily basis.
Yeah, of course, in my own practice, I know how to transcend time by just...
I need to learn that from you. I have to learn that from you.
That goes, once you stop thinking, there's no time, because time is the movement of thought. In my opinion, that's another metaphysical concept. But now, let me ask you another question. What was the location of the Big Bang?
Oh, it was within the observable volume of the universe, what we can see with telescopes, conditions were the same, almost the same, to 1 part in 100,000 as you go to the early cosmic history. And so the entire universe is expanding, or if you go back in time, contracting, and the density is the same everywhere. So it's not at a particular place, but there is just a special time when the density was infinite and everywhere that we can see.
So the Big Bang occurred everywhere and contained all time.
Right. There is no center to the universe. You see, that's why Aristotle was wrong, that in fact, there is no center because conditions are the same in everywhere early on in the early universe. So everywhere, the density of matter was infinite at the same time, and that's the Big Bang.
So then Galileo was wrong. It's just the Earth seems to be going around the sun from this location.
Yeah, I mean, he was just describing the local environment that we have. He was right about that the Earth moves around the sun. But in the global scheme of things, the sun moves around the center of the Milky Way, and the Milky Way is one, as you mentioned, one of trillions of galaxies. But if you go to very large scales, the universe has roughly the same conditions, to 1 part in 100,000.
Next question. So this is very interesting because now we are actually saying creation happened in a way that it was omnipresent everywhere. Omnipresent everywhere. There was the same laws of nature everywhere, omniscience. Okay, omnipresence, omniscience. And there was the same energy everywhere, omnipotence. So Big Bang is describing omniscience, omnipresence, omnipotence.
Yeah, I would agree with that.
Okay.
Except for the word creation, because maybe nothing was created. It was just, it existed in some other form to start with and then turned into what we see. Yeah.
I like that. Maybe it wasn't creation, maybe it was just transformation of
Yes.
what we call metamorphosis in a sense.
Exactly.
Not logically, but cosmically. Next thing which people ask me about all the time, what's this whole problem with the cosmological constant?
Oh, that's just the energy of the vacuum. The vacuum we are used to thinking is empty.
Mm-hmm.
And I have actually a Scientific American essay just on exactly your question. It turns out that in quantum mechanics, the vacuum is not empty. There are all the time virtual particles created and annihilated in it. So it could have some energy density associated with it. And usually it doesn't matter, but for gravity, it matters. And so only for gravity it matters, and then it affects the expansion of the universe. So as the universe expands, eventually matter gets diluted to a point where the vacuum starts dominating the mass budget, because the vacuum doesn't expand, it's fixed, it doesn't change. And the matter gets diluted as the universe expands. And it so happens that our universe recently, roughly at half of its present age, the vacuum started dominated. We see that in the way that it expands. According to Einstein's gravity, if the vacuum dominates, the expansion is accelerated. And the Nobel Prize in Physics was awarded for the discovery that relatively recently, the universe started accelerating its expansion, meaning that the vacuum, the cosmological constant, exists. And that's a big headache for physicists, because why would the vacuum have just the energy density needed for the acceleration to start recently? Why didn't it have much higher values?
And also the observed value is very drastically different from the theoretical value of the...
That's right. That's right. To show you once again that when physicists brag that we understand reality, one should take it with a grain of salt. Modesty is key. The knowledge we have is only an island in an ocean of ignorance. We don't know many things. We don't even know what most of the matter in the universe is. We call it dark matter, and that's just a label of our ignorance. So, my point of view is we should be modest and learn about nature by doing experiments rather than say, oh, we know the answer. And because if you look historically, whenever we were arrogant, we were proven wrong. Our imagination is not as rich as nature's.
So given the fact that no cause can be ascribed to the Big Bang, given the fact that the cosmological constant observed and theoretical is totally off by 1 to the power of 120 something. And given the fact that cosmic inflation at the Planck epoch was 10 to the power of minus 36 to minus 33, a fraction of a fraction of a fraction of a fraction of a trillionth of a second, how come so precise? It starts and then it suddenly slows down and stops mathematically. And that's the explanation we have for our universe. There
Right.
seem to be, given that there's 70% of the universe is dark energy, 25% is dark matter, 4% is atomic. Of that 4%, 99% is interstellar dust, which is invisible. The visible universe with 2 trillion galaxies is about 0.1% of the universe. And
Right.
that's our theories are based on just that right now. Uh,
Well, but I should say, you should look at this like we only know the account, like an accountant, saying to you, how much money was allocated to different things. It's not a very deep understanding. We don't know what the purpose of these different things or why were they set to have these values. We're not playing the role of the CEO of reality that says, this is my plan for how the universe should behave, and that's why I chose these values. We don't have that picture. All we do is measure these parameters and we realize their values. Now, some people suggested, oh, these values were tuned to have the conditions we see so that we will exist. Because otherwise, if we didn't exist, we wouldn't be able to ask those questions. This is called the anthropic argument. And I don't like it because, this is, in retrospect, this explains anything, so there, I agree with you. There must be some deeper reason for all of these constituents that you mentioned, and we don't have a good explanation for them right now in the context of science. Yeah.
My last question for today, and then next time, if you're amenable, we'll go a little deeper.
Mhm.
But I will be happy to send you at the end of this interview a conversation between Einstein and Tagore that happened in the Indian philosopher, sage, poet, seer Rabindranath Tagore in 1930.
Yeah, I know about it. Yeah.
You know about it. So right now, in the philosophy of science, the term is being used naive realism, that Einstein, despite his genius, was a naive realist in that he took the picture of the world as experienced by the human nervous system as the real picture of the world. And that means that what we see as the universe is exactly how it is to the 5 human senses, which is less than 1% of the acoustic or any other spectrum, visual spectrum. That's naive realism. Somehow the universe responds and correlates with the activities of the human brain, not the dolphin brain, not the crocodile brain, not the bat brain, not the butterfly brain. So we are taking naive realism as a testimony for truth. Is human truth the only truth?
I don't think so, not necessarily. And by the way, this comes back to finding others, because if we do find another civilization, another culture, we might get a different perspective on reality, right? Because they might view things differently. And we can learn from them. We can learn from bad practices. If, for example, they destroyed their planet through a nuclear war or not caring about the climate, then we can perhaps get our act together and avoid a similar fate. But if we ever establish a communication channel where we can understand their perspective, then we can get a better sense of what you just said, whether our perception of reality is limited to us. If they have a different perception, we might learn from the multiple views of reality that all cultures have. And that, I'm completely open-minded to that. I I think the biggest mistake that humans can make is to assume that everything resembles them. And that's, if going back to the analogy of my daughters, if they stayed at home, obviously they could think that they are the smartest, that the only way to view the reality is the way they view it. But once they went to the kindergarten, they got a different perspective. And we need to mature that way.
My very special guest today is Avi Loeb, professor of astronomy and astrophysics at Harvard University. And the book is called Extraterrestrial, the first sign of intelligent life beyond Earth. It's a captivating book. Please pick it up, read it. And Avi, next time, if you're open to it, and since you're a student of philosophy, can we discuss a little bit of Wittgenstein and Schopenhauer, and actually, most important, Immanuel Kant, who said, we can never know the thing in itself. We can only know what it is reflecting. And those are deep questions that are very relevant to science. So if you're open,
I'll be delighted. I really enjoyed our conversation immensely. And it's not very frequently that I have a chance to speak with someone of similar interests. And, that's one reason I established the Black Hole Initiative at Harvard, so that philosophers and scientists can speak. And I will be delighted to continue our conversation.
Oh, I look forward to that. Carolyn, the title today is the title of the book and then the subtitle of the book, okay?
Okay, got it.
Thank you. And then we'll send you an invitation. And Carolyn, can you send also some of the links to the talks with Don
and Frank?
Just Don Hoffman and Frank also, yes.
Okay, Don and Frank.
Thank you.
It was really a great pleasure. I must tell you, I had 100 interviews over the past 2 weeks, and yours was the most enjoyable.
Well, thank you. And, I'm engaging with Frank Wilczek also. So these are conversations that will expand, and I think they'll expand everybody's awareness also of what academia is doing.
Yeah, you are asking very insightful questions, and I learned from the conversation with you. You see, most of the discussions, I don't learn anything new, but with you, I learn new things. So
thank you. Thank you very much. Thank you, sir.
Bye-bye.
Thanks, Avi.